All right, so I'm going to go over the solutions to the review for your assessment number 3 for Algebra 2. All right, so here we go. First thing you're asked to do on number 1 is to label the vertex and the arrows with coordinates. So the vertex obviously over here at 3, 0. All right, now the arrows, so we mean like infinity. You know, this arrow over here is on the right side, so x is going to the right, so that would be infinity. And then the y value is going down, so that would be infinity comma negative infinity. On the left arrow, this is on the left side, so you're going towards negative infinity, and your arrow is going down, so that's negative infinity, negative infinity. So the y values are getting smaller. All right, so if you want to, right away, that's the answer to this end behavior as x goes to infinity. Well, we wrote that over here. The y value is negative infinity. And as x goes to negative infinity, we wrote that here, the y value is also negative infinity. So in these graphs in this chapter, usually both ends of the graph go to infinity or negative infinity, they kind of match. All right, so this tells us our domain as well. Your domain is the smallest to the largest x value. So if you look at your x values, there's no breaks or curves in this, breaks or holes in this graph. So here's the smallest x value and there's the largest x value. So you can easily just steal that for your domain. All right, so negative infinity to infinity, or you can put all real numbers, whatever you like there. All right, and in the range, you can look over here at your points too. The y values, these y values match. Whoopsie. These y values match, but then the x value, the y value up here is the highest. So my range is from negative infinity to 0. Right? So negative infinity comma 0 with the bracket because it's touching. All right, so you can also write that, y is between 0 and negative infinity. You could write this one, x is between negative infinity and positive infinity, if your teacher has you write it a different way, but either way is fine. All right, increasing and decreasing. So, anything that has a positive slope is called increasing, negative slope, decreasing. So this one kind of matches that. This side right here is increasing. So we are going to say it's coming from negative infinity to 3. That's where it stops. And so also what you can do is you can think to yourself, this whole side of the graph is increasing. So that pink area stops at the number 3 and it goes all the way to the left. So you'd say negative infinity to 3 with parentheses. And then the decrease area starts at 3 and goes on. So 3 to infinity. All right, x-intercepts. Well, I see one x-intercept. Sometimes there's 2. Sometimes, like if the graph is over here, you might see 2 x-intercepts, but it's not. So let's go ahead and our x-intercept is at 3, 0, that vertex right there. And y-intercept, I see this graph crossing the y-axis at negative 6. So I'm going to say 0, negative 6. All right, so just some questions. You don't always get asked those things, but all right, equation of the absolute value function. So I need some absolute value bars. This graph has been moved to the right 3. All right, so I'm going to put x minus 3. It has not been moved up or down, so I will not put anything outside. But in front of it, it's been reflected. And then I noticed that the slope is 2 over 1, down 2 over 1, down 2 over 1. Here it's up 2 over 1, up 2 over 1. So the slope is 2. So I need a negative 2. The negative is because of the reflection. All right, for number 2. So, number 2, f of negative 2. Oopsie, I forgot to put a g right here, so I need to fix that. So g of negative 2, so that would mean I'd have negative 3, negative 2 squared minus 6, negative 2, and then plus 10. So you can pop this right in your calculator, or you can work it out. This is negative 3 times 4. This turns into a positive 12 plus 10. So negative 12 and positive 12 cancel out, and so your answer is just 10. Of course, if you're going to put that in your calculator, make sure you put parentheses around all your negatives, and it's a good idea to put parentheses anyway. So basically what I wrote, negative 3, and then your negative 2 squared, all right, minus 6, parentheses, negative 2, all right, and then plus 10. All right, and pop this, right, same answer. All right, factor each problem. So we try to remind you here to do a GCF or look for it. So I notice everything in this problem divides by 2. So I'm going to pull that out first. So take out a 2, I get x squared minus 18x plus 32. All right, and so let's see, things that make 32 that also make 18. So I got 8 and 4, that's the most common one, but 8 and 4 don't make 18. But remember there's also 16 and 2, so I think that's it. So I have 2, I got x and x, I got 16 and 2. So if they're both negative, they add up to negative 18. If they're both negative, they multiply to positive 32. So there you go. On letter B, I do have another GCF. Both 75 and 12 divide by 3. So I'm going to pull a 3 out, and they both share an x. So I'm going to pull an x out as well. So 75 divided by 3 is 25. And now I only have x squared left, minus 12 divided by 3 is 4, and the x is already out front. So then I notice I have perfect squares. So 3x, I'm going to break the perfect squares up. 25 splits into 5 and 5 and put an x with each one. And then 4 splits into 2 and 2. So then I have 1 plus and 1 minus. So that when you multiply, the outside is negative 10x, the inside is positive 10x, and they cancel. That's why you see no middle term. All right, number 4. Number 4, you've been asked to draw the inverse. So remember, for the inverse, you reverse each point. So if I were you, I would kind of label these points, negative 6, 3. This one is negative 3, 0. And up here I have 0, 3. So I'm just going to reverse every single one of those points. So I'm going to start with negative 6, 3. So I'll go to 3, negative 6. So there's that one. And then that goes to this guy right here. So I'm going to do, let's see, negative 3, 0 would be 0, negative 3. So that goes here. So I'm going to connect those, that kind of go in order. Then I'm going to here, that would turn into 3, 0. So right there. So that way you get your picture in the right order. And if you want to, you can always check this. There's a diagonal line, y equals x, and these two graphs are symmetrical over that line. So number 5 is where you have to find the inverse, and you're given an equation. So remember, f of x is just another name for y. Okay, so I would switch the y and the x. I'd get x equals 4y minus 8. Then resolve for y. So I'm going to add 8 to both sides. So I got x plus 8 equals 4y. Then I'm going to divide everything by 4. So I have 1/4 x plus 2 equals y. And to be official, I was asked for this, so that means inverse. So I'm going to write f negative 1 of x equals, and here's my answer, 1/4 x plus 2. So you're going to notice that the slope, notice the slope here and the slope there, they're always reciprocals of each other. But, you have to do it because these numbers back here don't really relate in any, they do, but not in a way that you can tell. All right, so number 6. I got to clean this up. I cannot add 3 and 5. Do not add those together. All right, so you have to get rid of them. Take away 3 from both sides. So 5, I get 2x plus 4 equals 15. Then I'm going to divide by 5. So I get 2x plus 4 equals 3. All right, so I set this up into 2 equations. I get 2x plus 4 equals 3, and I have 2x plus 4 equals negative 3. All right, so take away 4 over here on the left, I get 2x equals negative 1, and so then I get negative 1/2. And for the other guy, I take away 4. When I take away 4 here, I get 2x equals negative 7, so x equals negative 7 over 2. And there's my 2 answers. All right, for number 7, I have to graph this, so it's an inequality here. So remember, I'm going to do some shading. So I'm going to start at positive. Let's see, it doesn't go left or right, but it does go up 2. So it starts up here. My slope is 1/3. So I'm going to go up 1 over 3. And don't forget, this is a dotted graph. All right, so I'm going to dot that. It's dotted because there's no equal bar here. Okay. And it says to shade less than, so I shade everything underneath. All right, that was the last problem, right? Yeah. All right, so on to number 8. So each picture below has 2 equations, or two functions, or not functions, but 2 equations graphed on there, and you want to know if they relate to each other as inverses. So one thing you could do is you could split the graphs. Draw this y equals x line that's supposed to split them in half, or supposed to be symmetrical, and you can kind of clearly see, hopefully, that this guy and, let's see, this one, they get kind of split in half by, or they're symmetrical over that green line in the middle. You can also do another thing. You can check some points. This guy has negative 2, 3 right here. So I should see 3, negative 2. So I see it. This one is 0, 2, And if you write 0, 2, then the reverse is not 0, negative 2. That would be wrong. Did you need... All right, so over here, let's see, I have negative 1, 2, and then I have 2 negative 1s. Those match up. You can also do more points if you need to. Over on the last one, I have 2, 0, so the reverse of that would be 0, 2, but that one is not it. All right, so number 9, we got some function operations. So this right here is composition. I'm going to take f of x and put it into g of x. So let me write g of x down. I got 4 something plus 7. So in that blank space, I'm going to put 5 minus 2x. And then you work it out. Remember that it replaces the x. You do not put the other x there. So I get 20 minus 8x plus 7. So if I fix that up, combine like terms, I get negative 8x first plus 27. That would be my final answer. All right, letter B over here. Letter B says to add these two functions. So remember, this is just a way to write f of x plus g of x. All right, it's just another way to write it. So if I add these two up, I got 5 minus 2x plus 4x plus 7. So the negative 2x and the 4x add up to 2x, and 5 plus 7 is positive 12. So there we go. All right, and then letter C, I'm subtracting. So subtracting, it's good to put parentheses, like I did with adding, but it's more essential here. So I got 4x plus 7, subtract 5 minus 2x. So I got 4x up here, and a minus 2x there. But remember, it's 4x minus a minus 2x. So it turns into 4 plus 2. So that's 6x. And I got 7 here, minus 5, so positive 2. All right, number 10. So this is composition, but it's using a number. So remember, the best thing to do here is to go ahead and plug in negative 2 into g. Like, just find that answer. Okay, so here's g. I'm going to put a negative 2 in my x squared minus 11. So you can put that in your calculator, or this is 2 times 4 minus 11, so that's 8 minus 11, that's negative 3. So that means now that this is negative 3. So I want to know f of negative 3. All right, so I'm going to plug that into this guy. So I have a negative, parentheses, negative 3 squared, plus 5 times negative 3, and then plus 10 on the end. All right. So this negative 3 squared part makes positive 9, but then there's a negative in front. So I have a negative 9. This turns into minus 15, and then plus 10. So you get negative 24 plus 10, or negative 14. So negative 14 is your answer to that whole thing. Or, you can pop this guy right into your calculator, this whole thing right here. All right. On to the last couple. So here, number 11, I got to clean this up. There's a negative on the right side, so let me add 7 to both sides. All right, so I got x plus 3 less than or equal to 5. So now this is a problem I can do. So remember, I do x plus 3 less than or equal to 5, and then I also do x plus 3 greater than or equal to negative 5. This is a less than, so you can put the word and in between. So take away 3 here, you get 2. Take away 3 here, you get negative 8. So your graph should come together. Less than or equal to 2 comes this way. Greater than or equal to negative 8 comes that way. So you have one contained piece. Your answer is everything between negative 8 and 2. All right, last problem here. So again, just like the first problem, I'm going to label these. Infinity right side, infinity going up. This is left side, also going up. So you could go and do your end behavior. Both ends are going up. So both of these would be positive infinity. My domain. So my domain, oops, I forgot my vertex. It is negative 1, 3. So my domain, just like the other one, is negative infinity to infinity, because that's the largest and the smallest x values. The range, the smallest x value is 3, y value is 3, and the largest is infinity. So 3 to infinity. All right, interval of increase. So in this one, the right side is increasing. So it is increasing starting at 1. So it's increasing this whole side over here. So it starts increasing at 1, and it goes increasing all the way over. So 1 to infinity. All right, and then the decrease part is the other side. So that comes from negative infinity, the white part, up to stopping at negative 1. Oops, I should have wrote a negative 1, right? All right, x-intercepts. So this one doesn't have any x-intercepts, so none. And again, if the graph was lower, it would cross the x-axis. So if there's 2 x-intercepts, you write them down. If there's 1, you write it down. This one has none. So the y-intercept, let's see, this is crossing right here at 4. So I'm going to put 0, 4. All right, and lastly, this I'm asked down here to say what movements. So remember this graph started in the center, and so it had to move left and up. So I would say that it moved left. You could say left 1, up 3. And if I check out the slope is still 1 over 1 here, so there's no stretch or shrink. And it's not upside down, so it's not reflected. So that would be it. Because the original parent function, the absolute value of x, looks like that. So this graph is different from the original by doing these things. All right, and that's what that question means. Good luck on your test. Bye-bye.